I hope this day is finding everybody well and healthy, and I hope that we don't have too much in the way of COVID in and around you. So wish you good health. All right. As far as this is our first webinar on valves. What I've tried to do in this webinar is to bring everything back to the basics. I'm trying to bring everybody back to the basics because we're all so far forward in our different criteria for selections and whatnot. A lot of us have forgotten what happens in the beginning. What are our first decisions we need to make when we're selecting valves? So it's sort of like we're trying to bring everybody back a little bit back to the beginning, and then from there, in later sessions, we'll take it a little bit further from there. So welcome again, and let's get started. As you can see here, okay, as a quick synopsis as to what we're going to be doing today, I've broken it down into 3 different sections. The first section is going to be basics for valve selection. Second section, you're going to have valve your different valve characteristics and your different seat characteristics that you can have, and then for the third section, the different functions of your valves. All right, that summarizes what I would like to do with you guys today. So here we go with the first section, which will be, excuse me, before I get into that, just to let you know, it's really important when you're selecting valves and check valves and different types of valves for your system. It's really, really important that you have an understanding of your entire system. It's not just a couple of quick little informations that we need to be able to make a proper selection. You really have to know your entire system to be able to make proper selections for valves and whatnot. So try to have as much information as you can on your system, try to know your system, and then even more importantly on top of that is that when you're making selections, try to get to know the products you're selecting as much as possible. There's lots of information in the brochures. There's lots of information available online, and of course there's us. If you're dealing with our products and whatnot, by all means, give us a call. It could be call your representative, call our customer service, and if you need my help, if I can be of assistance to you, my information is there also today, so you can contact me directly if you'd like. Not a problem. It'd be my pleasure to help you out. All right, first let's get on here. All right. Our fluid systems today are getting so dangerous. It's either our pressures and temperatures that are extremely high. It could be it could even be low temperatures. But our fluids, we're using so many different fluids. It's no longer just water and oils. It's like we're getting into some toxic materials that are flowing through our valves and through our systems. So systems are getting very complex, and in doing something like this, we want to make sure that everybody gets home at night so that they can get back to work the next day refreshed and ready to work. Keeping people safe is a huge portion of what we're doing. Okay, and as you know, as system designers, a huge portion of what you're doing is to make sure to keep people safe. You want to look at chemical. We will be looking at chemical compatibility, your external environments. Okay, and the different certifications and approvals that you can have for your valves. It could be codes. You may have to have valves that meet certain specific codes. It could be approvals like a CRN approval and whatnot. We'll get into that a little bit further. And also, I've broken this down into two different applications. Also, you've got your system applications and you've got your components specifications. All right, so it's broken down into 2. You'll see that as we go through it. Your component specifications, your valve functions, product, your quality. What kind of quality are you looking for? What kind of quality do you need to have? Okay, your different diameters, your sizing, type of actuation. Extremely important. Is this a valve that's installed 30 feet in the air and it's a manual valve? Well, you can't get to that valve to turn it on and off. So you may need to look at specific actuation. Your different flow capacities. Okay, your sealing designs, your seals, different types, different materials of seals that we can find on the inside of our valves. Your cycle life. Is it a valve that's going to be used once or twice, or is it a valve that's going to be used once or twice a minute, or once every second? These are all things that we need to look at, and we'll try to get a little bit more detail into that as we go along. All right, here, your valve functions. all of our decisions that are going to be making for the selection of a valve start with your first decision. Well, what do I need to do with this valve? Is it to turn a system on or off? Do I need to have overpressure protection? Do I need to make sure we don't have excess flows in the event of a breakage in the system somewhere? Is it to regulate flow? Do I want to regulate the flow, or do I need to direct the flow, send the flows into different directions? This is where the selection of your valve starts. You need to make these decisions first, okay? Which I think we all do it on a natural basis. So it's your first question that comes up. I'm just bringing it a little bit more to the forefront. All right, second question you're going to absolutely have to ask, and this is very, very important. You want to know what your pressure and temperature of your systems are. Pressures, of course, as pressures go up, or excuse me, as temperatures go up, your pressure capabilities are going to go down, and it can be quite dramatic. I've put in here two different types. You've got a table and you've got a chart. Okay. Now these two this is the way you will normally find as presented in Swagelok brochures. You'll find them presented this way. And don't forget, when we're dealing with Swagelok, I can't speak for the other manufacturers, but when you're dealing with Swagelok, all of our pressures, when we're talking pressures, we're always talking working pressure. You don't need to worry about figuring out safety factors and whatnot. They're fully integrated into into the different figures that you're going to be seeing. If I take the first table, as you can see here, this first table, on this one here, it's a very simple table. All right, it's valve X, Y, Z. It doesn't matter what the valve is, but it was just to show you the way that we show pressures and temperatures. As you can see here, temperatures. Okay, here we're going down as far as -20 to 200 degrees. This particular valve in stainless steel is good for 1,000 psi. But on the other hand, if we take our pressures and we go up in our pressures, as you can see at 400 degrees, we start to see a change in pressures, okay, pressure capabilities. And at 450 degrees, as you can see here, we're down to 800 psi. So therefore, your valve that you started off at 1,000 psi, because you're working at 450 degrees, that valve now is now been derated to 800 psi. All right. Excuse me. Very, very, very important, especially when we're dealing with temperatures. Very, very important to look at what your pressure capabilities are. As you can see with this one here, it may not be indicated elsewhere, but your pressure or your temperature range of this particular valve, okay, will be from -20 to 450 degrees. If you're operating outside of these temperatures, you're outside of the designed functionality of the particular valve. Okay, so at that point you could run into problems. All right, there's no reason to be working to take a particular valve and to be working outside of its parameters, its tested parameters. There's no need for that. We can find another valve which will meet the parameters that you will be working at. All right, and in this chart here, as you can see in this chart here, this particular valve has got a capacity of 6,000 psi. Now, this one here, as you can see, we have indicated here, this is your working pressure, and it's marked down here, working pressure. All right, 6,000 psi, and I'm going to be dealing again with 316 stainless steel. All right, but you can see this is the line for the 316 stainless steel. So we start at 6,000 psi at -65 to 100 degrees Fahrenheit. So, excuse me, I'm also dealing in Fahrenheit here. Okay, so 100 degrees Fahrenheit. As you can see, from that point onwards, we're having quite a drop in pressure capabilities because of temperature, till we get to about 500 degrees. And so you can see here at 500 degrees, we're down to about 4,000 psi. Now that's quite a difference. Okay, but as you can see, you're starting off with a valve that's good for 6,000 psi, but because of your temperature, it's been derated to 4,000 psi. So again, it's really important we look at pressures and temperatures. It's the crux of a lot of our decisions will be made using this type of charts and tables. All right. Next, your process fluid. Our process fluids are, like I was saying, are getting so dangerous now. We've got so many different chemicals that we're dealing with, and in so many different industries. Really important to know what our process fluid is. What I've included in here on this one here is a couple of photos. You can see a couple of valves here which are been seriously damaged. This particular valve here was a ball valve, It was installed into an oxygen system, or a system with a very, very high concentration of oxygen. Now, oxygen doesn't like abrupt on-offs in the system. So a ball valve in a high pressure, high concentration oxygen system is really not advised. Definitely try to stay away from that. But you can see in this case here, the technician had installed, or whoever it was that selected the valve, had selected a ball valve. And it was just, it's the question of the application of the valve and the system media were not compatible. Okay, so this, in this case here, as you can see, this is what was left of the valve. This is what we were able to find of the valve after the explosion. The center of the valve was completely gone. Okay, so this is something to keep in mind. The next photo, as you can see here, this is another one of our applications where customer had picked the right valve. He picked it is a severe service needle valve. So they picked the right valve for again another system of high concentration oxygen. So they picked a needle valve, which was great. The only thing that they forgot to do is they forgot to ask for it specifically cleaned. It's what we call, with Swagelok, it's called an SC11 cleaning, which we don't specify products cleaned for oxygen. We just specify the cleaning system, which if you look at the specification for cleaning of oxygen and our specification, they're identical. It's the same thing. Okay, but on this one here, they had, for the person that forgotten to ask for special cleaning, and of course, what had happened is the lubricant was non-compatible with a high concentration oxygen, and therefore we had a rapid burn, or a bit of an explosion and burn. Okay, so very, very important, you guys. Just got to keep that in mind. Keep it on going. Your chemical compatibility. Chemical compatibility. This valve that you're looking at here was in a hydrogen sulfide system. The hydrogen sulfide is extremely corrosive. It attacks many metals. And as you can see here, this in this first photo right here, you can see here, this is actually showing you the amount of corrosion cracking, or stress corrosion cracking, that we've got going on. This particular photo is actually an enlargement of the lip that you see in here. Okay, it's an enlargement of that, but you can see the cracking. And again, this is metal. This is a product that was passing through the valve that created all this damage. So just to let you know that there are systems out there which are quite dangerous, and fluids that are quite dangerous, even for people and for metals, different types of metals. This photo right here is the actual, that right there is the actual seat of the valve right here. Okay, but you can see how it's been completely eaten up and attacked by the hydrogen sulfide. So it's again, it's a bit of a difficult application. Okay, but when you've got a difficult application, you can deal with the company that's selling you the media. You can deal with them and find out exactly what materials are compatible with their medias. Okay, and if you can't get at that, you can always go through. There are commercially available chemical compatibility charts. All right, you can find that on the internet. As you know, you can find that in just about anywhere. All right, but if you can go back to the manufacturer of your media, it's even better. Okay, you want to look at the environment where the valve is being installed. Hey, is it being installed in a climate controlled, or we're in a process factory, we're in a factory somewhere where it's at 70 degrees, or is this valve actually being installed outside? And especially here in Quebec with our winters, minus 40, we do see, a little less often nowadays, but we do see minus 40s. So you want to make sure your valve is capable of handling that kind of temperature. Or in the second photo here, as you can see, this one here, is it an application where it's a valve that's going to be installed under the seat? Of course, you get down, you get down 300, 400, 500 feet to under in the ocean. You're dealing with some severe pressures. Okay, plus you've got the chlorides, you've got the salt water, which will attack a valve from the exterior going to the interior. Extremely dangerous for if you've got the wrong material under sea, and it could be on a gas line, a gas system. You want to make sure you've got the proper product. Okay, so your external environment, very important. And this is one that I included here. This was It was at one of my customers where it was a temporary installation. Temporary installation. Of course, there's nothing more permanent than something temporary. Of course, this valve here was installed in a very corrosive environment. You can see it was a steel valve which corroded badly. It was only there as a temporary fix, and of course, it stayed there a little bit too long. It had a chance to corrode a little bit too far. We caught this one in time. There was no damage. Nobody got injured. No environmental issues. So we managed to get to this one in time. All right. If you're looking at your different types of different ways of actuating a valve, you can have a standard lever handle, which I mean we're all used to seeing that type of a handle. Or if it's in an area where it's prone to getting accidentally actuated, you can go to an oval style handle. Okay, and if it's something even more serious than that, what we can go to here is what I refer to as a dead man handle. It is a handle which it requires someone to manually move it to another position. But as soon as that person lets go of that handle, the valve will return to its original state. That could either be excuse me, a normally open or a normally closed position. All right, but it takes somebody to move the handle, and as soon as they let go of it, it goes back to its original state. And you've got something like that right here. And another example of that would be, another example of it would be this one right here. This handle here, this yellow handle here, would be for larger size valves. Okay, and this is for a smaller size valve. This would be more in a lab, probably in a lab use, where you'd have to press on it, and as soon as you let go of it, it returns to a closed position. This one here is particularly to a closed position. Right. Of course, what we're all seeing in industry now, everybody wants to have locking handles. Okay, or you can go into what's called a latch lock system. Latch lock system requires two movements to make the valve function. One, you have to, if I can get my mouse working, what you want to do here is you press this in, and as you press it in, it unlocks the valve, and you're actually able to move it to its new position. Okay, and as soon as you let go of it, this little section right here will pop back out. So you can lock this valve either in an open position or in a closed position, but it will not, just by turning it, you cannot just turn the valve. You actually have to press that little lever in. So therefore makes it a very safe application. So if it's in an area where it's prone to getting hit, it's prone to be activated by accident, you just want to eliminate as many potential errors as possible, and that's what a latch lock system will give you. Is this valve going to be installed 30 feet in the air? Well, if it's 30 feet in the air, as an example, you're not going to be going up there on a ladder to go and activate a valve. So at that point, you can go to a pneumatic actuator, pneumatically actuated valves. Here you've got a spring return valve. This is a spring return, all right, to a double acting, okay, actuator, to a linear actuator, which operates up and down. Okay, now in a spring return, that can either be normally open, normally closed. Okay, so you turn your air on, as an example, turn your air on, it'll move the valve. As soon as you shut your air off, it will return the valve to its original position. Double acting, here with this one here, you can see it requires air to make the valve open, it requires more air to make the valve close. So you need air for both directions. And on a linear valve, it's the exact same thing, it takes air to open and air to close. Okay. Flow capacity. I know a lot of you are dealing with, or you're looking at your differential pressures. Okay, just a quick example here. To achieve a 1 gallon per minute flow through a 1/4 inch orifice. All right, if we look at a ball valve, okay, this particular ball valve has got a CV of 1.5. You will actually have with this a 0.7 psi differential pressure. All right. After that, you go into a needle valve. Okay, this needle valve has got a 0.5 CV of 0.5, and with something like that, you'll have a differential pressure of 6.5 psi. Okay, to a diaphragm valve. Diaphragm valve, as you can see with this one here, this has only got a 0.2 CV of 0.2, which creates a delta pressure of 35 psi. Okay, just to let you know, some of the things I know you guys are already looking at, but just bringing it to the forefront again. Okay, and don't forget, your CV is definitely, your CV is only affected by your orifice size, okay? Or shouldn't say only, but your 99% of your orifice is 99% of your CV, okay? The higher, of course, the higher your CV rate, as you can see here, 1.5 down to a 0.2. You can see the higher your CV rate, the higher your flow rates will be. Okay, and this is, by the way, these CVs, this is always supplied to you by a good valve manufacturer will always supply you your CV. It's necessary to figure out what your flows are. Okay, your different end connections. Okay, as you know, as you recognize this one here, of course, this is a Swagelok end connection or a compression end connection. Okay, to pipe threads. You can have your different end connections. It could be pipe threads. They've been around for a long time, so it's not something we can get away from. Pipe flanges. Again, pipe flanges, depending upon how your system is being put together, it may be pipe flange. You can have your valves with pipe flanges. Okay, to zero clearance. Zero clearance. The beauty of something like this is that zero clearance fitting requires no space. You do not need to move anything to be able to take a valve out of an application. Because frequently, to remove a ball valve that's threaded or remove a ball valve that's been threaded into place. Frequently, it's not just the ball valve you're going to be removing, you're going to be removing a section of piping to be able to get that one particular valve out of place. And the more you have to remove, of course, more time is required, so therefore more cost of maintenance. Okay, zero clearance fitting, it's simply the nuts that back up, and at that point the valve simply slides out of place. Real system, easy system to use. Okay, to welded. You can get valves that are, depending again upon your system. You may want to have welded valves in your system. It might be due to code. Maybe whatever you have going through there is considered dangerous enough. It needs to be in a welded situation. Could be something like that. For purity purposes, you may want to have your system welded also. Okay. And what I've included here, your cycle life. Again, as I've mentioned before, is that a valve that's being installed in a system where it's going to operate once a day, once a year, once every 6 years, God only knows, okay? Or it could be something that's going to be used, a valve that's going to be turned on and off once every 2 or 3 seconds. Very important to know, so you need to know what your cycle life requirements will be, okay? What I've done, and don't forget, any valve that you cycle it once, you're creating wear in that valve. All valves wear. It's a wearable component. All valves wear as soon as you move them once, they're starting to wear, okay? But I've included here some photos just to show you some of the different wear, because I'm sure with what most of you are doing, you're not going to be seeing that when a valve fails or there's a problem with a valve, you don't get to see that. But I brought these photos along to show you. This is a needle valve, okay, a regulating stem tip needle valve. Okay, and it has a metal to metal seal, and because you can see that by the polishing that's happened in this area here. But just look at some of the wear now. The length of time that this valve was in use, I can't tell you, but I'm just showing you some of the potential wear that you will find on your in your valves. To that one there, this is a ball valve, and this is a ball valve that was installed, and somebody decided to use it for throttling. Remember, ball valves are 100% open or 100% closed. They're never in between. You do not want to use a ball valve in between fully open to fully closed. All right, but you can see this particular one was used as somebody was using it for throttling, and this is the damage that was created to the seals. Okay, I don't know the length of time, but I know it wasn't all that long before this valve was no longer creating seals. It was no longer creating a proper shutoff. This is another needle valve. Okay, this is a soft seat of a needle valve, and you can see here that the wear that's happened in these areas here. This wear is a little bit normal. Okay, maybe this particular valve got a little bit too much wear, but when you're closing a soft seat, it's normal. You're closing that soft seat against a metal seat. Okay, so it's normal that you're going to end up with a little bit of usage on your soft stem. Okay, that's perfectly normal. So again, you want to look at there's a lot of things that come into play. Is it going to be cycled once in a while, frequently, very frequently? You want to look at that. And then it's a matter of figuring out what kind of cycle life, when do I need to get into this valve to do repair work? It may be after a very short period of time. It may be after a very long period of time. But all valves wear. Keep that in mind. All valves wear. Quality. How critical is the application? That's the big thing I always look at. How critical is the application of this valve? If this valve fails, okay, what is the cost of that failure going to be? Is it just a matter, oh, it's going to cost a couple hours for the guys to come in, change the valve? Or is this one valve that's not functioning going to stop a plant that's producing for the company $50,000 an hour? Is this one valve going to stop that production from happening? So you want to look at your quality and where is it going? What is the valve doing? Very, very important. Also in that, if it's a valve that's going to be operating at its max pressure, max temperatures frequently or all the time, at that point you want to try to go with the best of quality as you can find, because the cost of doing repairs and whatnot will significantly outweigh the cost of the valve, the purchase price of the valve. Okay. Your cost of ownership. Certainly the upfront price of your valve is important. Of course it is. All right. But you do want to make sure the valve that you're buying, can I get spare parts? Can I get spare seals? Can I get new seals? Or is it a valve that I'm going to have to remove the valve, throw it away, and put in a new valve? Or is it your labor to repair or adjust a valve? All right, is this valve installed in your plant, or is this valve installed an hour and a half by helicopter to go to an exterior site, if you want, a site further down the line, where you have to go in and do some repair work? Cost at that point, the initial cost of the valve is no longer an important factor. You want to keep your cost of maintenance down. So you want to look at your different costs and what it's going to cost you to replace that valve. And again, like I was saying, you want to make sure that the cost of the failure is not going to be, if it's a $100 valve or a $200 valve, you want to make sure you're not stopping $50,000 machine from working. Okay. Your different valve functions. Is the valve you're going to need, is it simply an on-off valve? Is it going to be for controlling your flow? Is it for directional flow? Is it for overpressure protection or relief valves, overpressure protection? Or is it for excess flow protection? Now, if you've got an excess of flow of a media that's escaping, which is extremely toxic or dangerous for the environment, could create a huge problem. Let's move on to the next slide here. Let's show you here on something like this. What I've done is I've put some photos. You've got photos of your different types of valves. Okay, ball valves as an example. You get photo and you've got a little design, the interior design to show you. Ball valves, great valves, very economical. So some of the most economical valves you can be buying. Okay, advantage is the economy is the advantage of this valve. The negativity in this valve is that of a ball valve is that you cannot use them for throttling. You can't use them to regulate flow. Butterfly valves, again, great valve. With the butterfly, the problem with that is that, don't forget that this disc right here, this disc is always in your media. So if you have a media which has got a lot of abrasiveness to it, for certain, the butterfly section of this valve could face some premature wear. Okay, so it's something to keep in mind. To diaphragm valves. Now, diaphragm valves, you can find diaphragm valves in huge sizes. I can't speak for the exact size that they're available in, but I know they're available in very large size, 24, 48, possibly even 60-inch diameters. Okay, and on the other end of the spectrum, they can also be used in the production of electronics or wafers and whatnot for electronic boards, etc. So, and this could be used for, again, a very small size, and it can be used for very specialized gases, as an example. Okay, the gate valves. And we've all seen a lot of different gate valves. Gate valve is very similar. The great thing about it is it's very similar to a ball valve. Okay, you've got very little restriction to flow through here. It's almost a full flow. You've got very little restriction. The only thing is in high pressure well, it can be used as a regulating valve also, but in high pressure, you can get a lot of cavitation and early wear of the valve as it is opening and closing, or if it's being used in the throttling situation, you can get a lot of wear in there. Okay, to a globe valve. Globe valves, again, great valve. Okay, open and close application. They can also be used for some regulating of flow. Okay, problem with them is that at high pressure, your valve it's quite a noisy valve at high pressures. Okay, to plug valves, great valve, very economical again. Okay, small sizes. It's not available in, well, excuse me, they are available. Some are available in larger sizes. But again, with a valve like this, disadvantage of it is that it is like a ball valve. It's a rotary valve. It is not designed for throttling. Okay, so you won't control any flow. You will not control flow with a valve like this. Okay, this is a slide. It's the resume of what I just went through with you guys. If you would like to have this, well, actually, you will be getting this because the presentation will be sent to you, so you will have this at a later date if you want to make copies of this for further information. Okay, needle valves. What do needle valves do? I have had technicians come to me and tell me, "Oh yeah, I use this needle valve to control my pressure." In the particular sense of what he was talking about, he was controlling his pressure because it was a system of with spray nozzles. Okay, so his flow, he would be able to regulate his flow, because in reality, all he was doing was regulating his flow. But to him, he would see on his gauges, he would see a pressure. But the reason he had a certain amount of pressure is because there was a certain amount of flow through these nozzles. Take one of those nozzles, block it. What happens to his pressure? His pressure starts to climb. Take another nozzle, block it. What happens to the pressure? Continues to climb. Now, if he's got something in that system which is sensitive to higher pressure, okay, at that point, he could wind up creating damage in his system. Regulating valve or a needle valve is to regulate your flow. It does not regulate your pressure. If you need to regulate your pressure, you need to go with a pressure regulator. Okay. I know at some point in time, needle valve will look like you're controlling your pressure, but block the outlets, and what happens to your pressure? Your pressure will be equal on both sides of your valve, or close to equal on both sides of your valve. Okay. I included this just to show you the interior, what's going on the inside of a needle valve. Excellent for controlling flow. That's what a needle valve does. It is to control your flows. All right. But some of the things on the inside that I wanted to show you is the location of your threads. Okay, your threads to make the valve function. Very, very important. Are they above your system media, or are they above your packing, or are they below your packing? If they're below your packing, they're into your system media. There's some medias where it really doesn't matter whether the threads are in there or not. Doesn't make a difference. There are other medias where they could wash out the lubricant that's on the threads. The lubricant of the threading could contaminate the system. So it's all something you do want to look at. So when we're dealing with needle valves, you want to look to see, okay, where is my packing? And of course, because I know my system complete, I know whether the packing, where the threads are, will make a difference. I know whether it'll make a difference or not for as far as the lubricant and whatnot. So it's something you want to keep in mind. All right. There also don't forget also that a needle valve is a directional flow only. Needle valve, on this particular needle valve, your flow is coming in this way and it's going through the valve, and in the reverse, as you can see, coming back, this will not work. There will be way too much turbulence in the system, will create too much turbulence, too much restriction of flow. So you don't want to, you want to use a needle valve in the direction of flow. Okay. Every needle valve has got an arrow indicated on it. You know where your inlet is, you know where your outlet is. Here's another example of what I was talking about. Know where your threading is on your stem. Very important. Okay. In this particular instance here, you've got your packing here. Okay, and your threads are above. But here's a very economical needle valve that you will find in industry. On this particular needle valve, you'll see here, as you can see here, the threads are within the flow. All right, so the lubricant that's on there could get washed out depending on what your media is. You want to be careful of that. To another application where here, as you can see here, this is actually using an O-ring, okay, to create a seal around your stem. Is that O-ring going to be attacked by your system media? All important things. You have to look at those things. Okay, and let me see here. Sorry about that. I'm having troubles with my slide here. Hang on. Oh, there we go. Okay, your different types of stem tips that you can have in a needle valve. Okay, what I've done here is this particular stem here is actually what we call a non-rotating ball stem, but at the same time it has a sort of a V shape. You can see it's sort of got like a V shape. And what I've done is I've taken out a graph to show you a V-shaped stem tip. Okay, once you reach number of turns open, once you've reached 2 turns open, as you can see at this point here, your valve is 97%, 98% open. All right. Whereas when we get into your different stem tips, these are regulating stem tips. One has a metal-to-metal seal, and the other one is a soft seal. But you can see this section here. This is the section of your valve which actually gives you your regulating stem tip. It's here, and on this one, it's here. You can see both of them have the same shape. One has a metal seat, one has a soft seat. You don't want to use a metal seat if you're dealing with gas. It's not the best seat to be using. You want to be using a soft seat if you're dealing with gases. If you're dealing with liquids, metal-to-metal seat normally will be great. All right, but you can see here with these regulating stem tips, look at the number of turns to open. Okay, so I've got 5 turns. I've got to go full 360 degrees 5 times to get those valves to be completely open. It's a slow opening. It's a slow closing. And again, depending upon what our system is it a high purity oxygen system, or is it a steam system where we don't want to shock the system with a rapid opening? At that point, we can go with a valve something similar to these. All right, gives you much better control over your flow, and it's slower opening, slower closing. Okay, let me get to here. This one here. This is an extreme case of a regulating stem tip. Okay, I'm going to call it an extreme case. This is what we call a fine metering valve. You can see this section here. Okay, this section here is your regulating stem tip. But you can see how long that is. The longer it is, the more control you have over your flow. Okay. Now this particular valve, okay, is only available in small sizes. It's not available in large sizes. It's only small sizes. But this permits you to have an extremely precise control over your flow. You can take a 10 gallon per minute flow, and you can drop that down to a couple of drops per minute if you'd like with a valve something like this. Okay. This particular style of valve is not used for opening as a shutoff valve. This would not be a shutoff. This is strictly a control valve. Okay. The other needle valves we were looking at was the soft seat and the hard seat and the metal-to-metal seats. They can be used as shutoff, but in a fine metering application, they are not used for shutoff. They are just used to control your flow. Okay. All right. Directional. From there, we get into directional control. A two-way valve is not exactly what we would refer to as a directional control. It's on-off. But once we get into a 3-way valve, 4, 5, 6, 7-way valves, these are multi-port directional valves. You can control the direction of your flow. Okay. To give you an example on a 3-way, all of these valves are bidirectional valves also. But on a 3-way, as you can see here, a 3-way valve, you can either have 2 entrances and 1 exit, or you can have 1 entrance and 2 exits. Okay, you can select. It could be a selector valve, or you could be like I said, in either direction. You can select either direction. Okay, to a 4-way valve, where the beauty of a 4-way valve, it could give you the possibility of eliminating an extra valve. Sometimes just 1 valve will do the job of 2. Okay, so 4-way valve and a 6-way valve, you might be able to eliminate an extra valve out of the system. To a 5 and 7-way valves, these are again selector valves. 5-way valve, you can have 1 entrance, 4 outlets, or you can have 4 inlets and one outlet. All right, and it's the same thing on a 7-way. So you can use these again bidirectional. We use them adapt to the system that you need. Right? To special drilling. Again, this is what we're looking at here. It's a simple three-way valve, but you can have that with special drillings, okay, to do specific jobs. All right. And this information is always it's in the catalogs. You can find that, especially with Swagelok, you can find that in our catalogs. And if you need more help, by all means, give us a call. I'd be more than happy to help you out with that. But these are just it's a multi-port ball valve with special drillings we can help you with. From there, we go into check valves. Check valves. What is the job of a check valve? Check valves ensures that you have a flow of fluid in one direction and one direction only. You're not going to get you're not going to get a backflow through a check valve, as you can see here. Your normal flow will be from left to right with this particular model, the way it's set up. Your flow would be left to right. Okay, and as you can see here, as soon as there's enough pressure, the poppet here, this is your poppet. That is all your poppet. That poppet will open, allowing a flow. Okay, but in the opposite sense, if there's a backflow that happens, it will rapidly close. Okay, and of course we're using a spring in there to assist in the closing, keeping it closed, and to limit the amount of opening also. Something we get this quite often. Customers will call up and say, yeah, well, I want my nominal cracking pressure is, but it doesn't open at that pressure. Why? And then the reseal pressure. All right, so we've got a chart here, as you can see with this chart here. If you've selected a valve that's got a 1/3 psi cracking pressure, it's not going to always open at 1/3 psi. It could take up to 3 psi to get it to open. It all depends. How often has the valve been used? Has it stuck in place? Has it not functioned for a long period of time? Or did the media create a stickiness and it doesn't allow the poppet to open easily, as an example? So this is why we say a 1/3 psi could take up to 3 psi to open. But more importantly, what you've got to look at is you actually need 6 psi of back pressure to seal this valve. Okay, so 1/3 psi cracking pressure could require up to 6 psi to get it to seal. If I was to go as an example, just take the extreme. If I go down here to 25 psi cracking pressure, and this is again for a system, let's say it was 100 psi air. 25 psi to open, it's going to be running at 100 psi, so it's going to be open instantaneously anyways. Okay, it will require 20 to 30 psi to get it to open. Okay. The nice thing about something like this is because your spring has got so much strength to it, once your inlet pressure declines to 17 psi, okay, it will close, the check valve will close automatically. All right, so there, in comparison with this cracking pressure, this spring here, this cracking pressure here, this one here doesn't require back pressure. All it requires is a lower inlet pressure, and it will create a positive seal for you. Okay, really important in a lot of different systems. And people ask me, they say, well, it's a check valve. Yeah, I just need it to open right away, but I'm at 100 psi, and people will select a 1/3 psi. I try to guide them away from that, and I try to show them their reasons of why, as I've shown you here. Okay, check valves, just to show you some of the different check valves that there are. This is the one we were looking at before. It's a poppet check valve, okay, to a lift check valve. Okay, as you can see, it's quite a difference. All right. Now, I had an example with one of these check valves in a pulp and paper industry. The water that they were using had a lot of wood fibers in it. All right, and those wood fibers, they're using this kind of a check valve. Those wood fibers would get entangled into the spring in here and would create a blockage and would not allow the poppet to move properly. They were going in, they had to clean these things out frequently. It was creating a bit of a problem. And I went in and I had a look at their application. And once I saw just how much fiber there was in the water, I made the suggestion that we would go to something like this, which is a lift check valve. Lift check, as soon as you had a pressure here, it pushes up, because again, this is only held in place with gravity. It would push us out of the way, of course, you get a flow through. If there was a back pressure, well, because it's gravity, and as soon as you cut the pressure, this poppet would close automatically. On top of that, add a back pressure, is creating an even better seal, because the back pressure would come up here, push down, and create an even better seal. So it was in just making a small change of the style of check valve, we were able to eliminate all kinds of problems in their system, eliminated a lot of maintenance costs for them. So again, it's my pleasure. If we can help out, let us know. We'll try and get out there to help you with your application. Okay, the difference between relief valves and check valves. Because I've got customers who say, "Oh, Brian, I need a overpressure protection of 25 psi." And as you saw in the previous slide, you can have 25 psi opening pressure. Problem with that, check valves are designed to, when they are functioning in a normal system, they're actually meant to be open. Okay, they're not meant to be closed, they're meant to be open. All right. Whereas with a relief valve is designed to be in a normal position, closed. Okay, should there be a problem with the system, an overpressure of the system, because your pressure will be coming in here, overpressure of the system, it will push on your poppet or your stem. It'll push on your stem, which of course is held in place with a spring, but it'll push on that. It'll allow a flow. It will dump pressure, and then because of the force of the spring, it'll automatically close it. But again, pressure relief valve is designed to be normally closed. Check valve is designed to be normally open. Two different games. All right. I will never suggest you use a check valve as a relief valve. It's too risky to end up with some damage. Okay. Two, and we get into here. Here's a relief valve. Okay, to show you again, relief valve. And as I was saying before, just this is a little more exploded view. Your pressure here would come. It would of course push on your stem, or you push on your stem and allow flow through. All right, and then once that happens and the pressure goes back down, at that point the poppet here will automatically reseal. To a safety, oops, that's actually the wrong photo. Let me see here. That you're actually looking at here. So I'm sorry, you got the wrong photo. A safety valve is actually a valve with it's actually got a large handle to it. Safety valve, what will happen is if there is an overpressure situation, the safety valve will pop. Okay, it gives a loud popping sound. It'll pop to an open situation, therefore allowing your excessive pressure to evacuate. And at that point, to reset it, it takes a technician that comes along. He has to push that handle back down to reset your safety relief valve. When you reset the safety relief valve, the idea there is that they've got a technician there to look to see what is the problem, why did this happen. All right, and they're designed to have somebody come by and reset it. To a safety relief, this photo here is of a safety relief. It functions just like what you had seen before, one of our relief valves, or the first valve you saw was a relief valve. The difference with this one here is that at 110% of its original set pressure, it is 100% open. Whereas with a relief valve, the first valve you had seen, at 110% of its set pressure, it may not be 100% open, it may be only 10 or 20% open. But these are designed to, as soon as there's an overpressure, you've got 10%, you've got a 10% range to play with, and once it's 10% over, it goes to 100% open to evacuate the pressure as quickly as possible. Again, it's to save either the equipment, to protect the personnel, and to protect the plant. Okay. Your overpressure, your valves, your overpressure protection valves. You want to look at your set pressures. Okay. And if it is being used as a safety valve, you may want to look at doing periodic maintenance to make sure that that valve is functioning as it's supposed to. Something that's very, very important. Is it a viscous fluid? Is it liquid asphalt, or is it a beer system? Two totally different viscosities. It's something just the same. It's very, very important to look at. Okay. And do you want this overprotection to give you a bit of a back pressure? There's some of the things that the different valves will do for you. You want to look at your connection size, your temperature. Temperature, again, know your system, your complete system. Your temperature, again, is a very important factor again. Okay. And the last valve we're going to look at today, I don't know if there's a lot of you that have seen this. It's what's called an excess flow valve. Excess flow valve is designed to protect, again, personnel, environment. It protects against an uncontrolled evacuating of your media. And I'll give you an example here. It sort of looks just like a check valve, right? It looks like a check valve, sort of operates, it looks like it might operate the same way, but actually it looks like it, but it operates totally differently. What you've got here is this poppet. Hang on a second here. My mouse to work again. Here. This poppet here in blue. Okay. Its normal position would be something similar to this. This is its normal position. You've got flow going through your excess flow valve, okay, because it's supposed to have a flow through it. You've got flow going through, flow is going through and exiting, all right? But now let's say for whatever reason, you either had a break in your system or somebody inadvertently opened a valve, which can happen. Somebody can accidentally open a valve and suddenly you've got a huge increase in your flow. At that point, what will happen here, again, this is the blue section here, this blue here is the poppet. As you can see, it has moved from here, okay, which looks like it's closed, but it's not actually closed, to this position here, which actually closes the valve. It will limit 95. Sorry, it will limit 95% of your fluid flow through this system. It will allow 5% to continue through, and in doing so, the 5% that it's allowing to go through. Once that valve has been closed or the correction has been made in the system where the break has been repaired, it will allow flow through the valve, okay, until the pressure equalizes. At that point, the valve itself automatically opens. So it's less maintenance. You don't have to have somebody. I don't have to send somebody in to go and do maintenance on it to get it to reset. It will automatically reset, but it will have cut. Like I was saying, it cuts 95% of the flow from escaping openly. All right. Just to sum this up, some of the things I'd like to make sure that you do keep in mind. Okay, you do need to know, and it is imperative that you know the entire system, know your whole system, know what it does, know how it's cleaned, know the different parameters, temperature spikes that you could get. You do need to know these things when you're making your selections. So keep that in mind, please. Your media. All right, get the manufacturer of your media, get them to help you with the selection of different materials as far as for your alloys of your valves, your seats, different seat materials, what seat materials are compatible with that media. It's really important, and like I was saying, if you have to, you can always go to a chemical compatibility chart as a last resort, but try to deal with the manufacturer of your media if you can. Okay, and by all means, please read your catalog completely, or the brochure on the valve that you're selecting. There's lots of information in there. If you don't have the time to read, you'd rather either go through the reps or go through our customer service. We're there to help you. We're there to make sure you make the right selection, or we're there to help guide you through making your proper selections. Okay. If you have any questions, if I can be of any assistance, it'd be my pleasure. Let me know. You can contact me either by email. There's my cell phone number. It'd be my pleasure to take a call. My pleasure to answer emails. If I can help you with anything, please, by all means, let us know. If you need your webinar certificate of attendance, just send a quick note to Solange. She'll take care of you for that. And check your mailbox. There's going to be information coming to you shortly. I think it's in the next 3 to 4 weeks. So the information will be emailed out to you on our 60 series valve, just to try to help you with making your selections of valves, and it'll give you a chance to get to know our 60 series valve. Oops. And your next training, which will be coming up, I believe, it's in April, will be on your different certifications and conformities, either for different codes, certifications, CRN numbers, certificate of compliance. Thomas has got lots of experience in this field, and he will be able to help you with that. And that'll be on the 8th of April. So please keep an eye open for your through your emails for the next seminar that's coming up. And that completes what I wanted to do with you gentlemen today, or you ladies and gentlemen, excuse me. Again,